All right, let's get straight into it. Welcome to this explainer tailored specifically for our Genesis International College carpentry students. Today, we're diving into the high-stakes, incredibly physical mission of erecting formwork. Honestly, whether you're stepping onto a residential site or a low-rise commercial project, this right here is where your foundation in the trade truly begins. As a future formwork carpenter coming out of Genesis, you've got to realize something huge about your role. Your job out there on the site isn't just about nailing bits of wood together. You are literally the ultimate gatekeeper of the building's structural integrity. You're the one shaping the very skeleton of the structure way before it permanently sets into stone. And this brings us to a quote that perfectly sums up the gravity of what we're doing today. If the mold for the concrete is inaccurate, the entire structure may fail. It's terrifying, but it's true. If your formwork is off, the whole thing is compromised before it even leaves the dirt. Honestly, it won't matter how incredible the bricklayers or the roofers are later on if you don't get this right. So here is our game plan for today. We're going to walk through this entire mission chronologically. We'll start with the critical first step, then decoding the site plans, preparing the ground, setting the footprint, erection and bracing, and we'll finish up with surviving the pre-pour inspection. Let's go. Step 1, the critical first step, which is establishing the legal framework on the ground. What we mean by that is translating the National Construction Code, the NCC, into a physical reality. That rulebook dictates every single hammer swing you make on site. Basically, the NCC demands your formwork guarantees 4 specific things. First, structural stability so the footings carry the load. Second, it has to support the immense, totally unforgiving weight of wet concrete without blowing out. Third, damp proofing, which means hitting precise slab edge heights, usually right at 150 millimeters above ground level. And fourth, it must hit rebate precision so moisture and termites have absolutely no chance of breaching the timber frame later. All right, moving on to step 2, decoding the site plans. These are essentially the secret codes of a successful build. Before anybody starts building, we have to transition over to the site plans and crack the shorthand codes that dictate our every move. You really need to become fluent in this language. So memorizing these abbreviations is an absolute must. FFL, that's finished floor level, the absolute final height. NTS is super critical. It stands for not to scale. That means you follow the written numbers. Do not, under any circumstances, just measure the paper with a ruler. Then we've got TO for top of, like top of slab, and TYP for typical, meaning a detail applies everywhere similar. Misinterpreting even just one of these can lead to non-compliant work, and trust me, that is insanely expensive and difficult to fix once that concrete cures. Which brings us to step 3, preparing the ground, the very foundation of the form itself. When we move out to the physical site, you quickly realize you just can't build a precise mold on a chaotic surface. You have to ensure the ground is meticulously prepped. That subbase your formwork sits on, it needs serious attention. In fact, NCC Part 4.2.3 specifically demands clean-cut excavations with perfectly vertical sides. The base has to be totally free of loose earth, mud, or any random debris. You're looking to confirm the exact elevation and gradient because having a stable foundation is completely mandatory before you lay down a single piece of timber. Okay, step 4, setting the footprint. This is all about mathematical precision. Marking out the footprint is exactly where your theoretical knowledge meets the dirt. It demands strict precision. First up, you establish a fixed baseline, which is usually a boundary setback. Second, you set up your profiles or batter boards. Make sure they're at least 1.5 meters away so they don't get wrecked by site traffic. Third, run your perimeter string lines. And fourth, drop exact plumb bobs down to the ground. That sequence right there is how you achieve millimeter-level accuracy. Mastering this specific 4-step marking discipline is your absolute best defense against parallax errors. Because think about it, a string line suspended up in the air is basically useless unless you can accurately project it straight down onto the dirt where the actual formwork is going to sit. Dropping those plumb points perfectly is what ensures your 3-4-5 triangle method for squaring actually works in reality and not just on your blueprints. Moving right along to step 5, erection and bracing, or as I like to call it, holding the line against the surge. So once that footprint is perfectly set, we step into, by far, the most physically demanding phase of the job. Installing the actual forms and tying down heavy steel rebar is where your perfect geometry comes face to face with gritty reality. It's really tough work out there in the trenches, but it still requires a delicate touch to keep everything perfectly aligned while you're working inside the box. Now, when wet concrete pours, it brings immense hydraulic pressure. To combat that and avoid a disastrous blowout, you have to expertly deploy three main defenses. First are kickers, short diagonal braces that stop the base from kicking out under pressure. Then you have raked braces. These are longer, they support the top and actually give you the leverage you need to plumb the wall. Finally, the dead man. This is a massive timber block or a huge stake driven deep into the earth, acting as the ultimate, immovable anchor point for your braces.
But hey, brute strength isn't the whole story. Your bracing also has to maintain incredibly strict workplace tolerances. For example, your slab edge line. It must be straight within just 5 millimeters over a 3-meter run. Your form faces need to be clean, smooth, and lightly oiled so they actually strip off easily later. The squareness of your diagonals has to match up tightly, and your topper form must match the FFL datum exactly. Make no mistake, high-quality formwork is what guarantees a high-quality slab.
And finally, we arrive at step 6, the pre-pour inspection, surviving the final check. This right here is the climax of your mission. Before those concrete trucks even pull up, you're going to hear the term hold point a lot in this industry. A hold point isn't just a friendly suggestion. It is a hard, legally binding stop sign. Work absolutely cannot proceed until the certifier, engineer, or supervisor scrutinizes every single millimeter of your work and provides a formal sign-off. Before that pump arrives, inspectors are going to look extremely closely at details just like this. They need to ensure that all internal plumbing and electrical services are protected from the massive weight of the concrete slug, and that the rebar is spaced correctly and wire-tied securely inside the forms so it doesn't sink or shift during the pour. To actually snag that crucial sign-off, you've got to clear a 3-part checklist. First, bracing stability. You physically stress test your braces, give them a solid hit. If they rattle now, they're going to fail under the concrete pressure later. Second, debris removal. You have to completely clear out all the sawdust, soil, and offcuts from the bottom of the forms. And third, joint tightness. You inspect every intersection to make sure they're flush and gap-free, because if they aren't, you're going to lose that critical concrete slurry right through the cracks, which severely weakens the final slab. So as you pack up your tools today and get ready to step onto the job site tomorrow for Genesis International College, I want you to ask yourself one question. When that concrete starts flowing, when the intense vibration starts, and that hydraulic pressure violently spikes, is your craftsmanship truly ready for the test? Thanks for joining me on this explainer, and I will see you out on the site.